Well, hi everyone. Gonna work on this practice test. And it's kind of set up like what you will see when you take the test. So the first thing here is we are going to solve a system. This is not an inequality. These are just equal signs. So we're going to graph both lines and look for the point of intersection. Graph both lines and look. We're studying, right? So we'll write down some notes here where we do this. Okay. So I'm going to graph this first one in blue. Y minus 3x equals negative 3. Alright, I am real tempted just to add 3x to both sides here, because then I have it in slope-intercept form. I'll put the 3x first, the minus 3 second, and here is m, and here is b. So b is negative 3. Then I'm going to go 3 over 1. So go up 3 over 1. I'll do that. I'll fill up my down 3, left 1. Okay. And let's see. Use a pink note card for straight edge here, because if we're solving by graphing, we need to make a decent graph. Alright, so I'll go right there with that one. In red, I will graph this one. Now that's already in slope-intercept form. 1, 2, whoops, from here. 1, 2, 3, 4, 5. 5 is the y-intercept. We'll go up 1 over 3. Ooh, looky there. That's hitting the line already. But I'm still going to draw the complete line as a matter of style here, maybe. No, okay. And then we're real interested in the solution. Is this point of intersection, which is at 1, 2, 3, 1, 2, 3, 4, 5, 6. At 3, 6 is that point of intersection. My final answer is xy equals 3, 6. Put 6 here, put 3 here, you'll get that answer. Put 6 here, it'll equal 1/3 times 3 plus 5 here. You'll get that answer. This is the solution. That graphing is one method for solving systems. Another is substitution. Okay, and you have different ways. If you're doing this, if you've done this before the video, you might choose a different way. But get a variable by itself in one of the equations. And I like to make it as easy as possible. So I think that first equation, you can solve for the x or solve for the y. I'm going to just solve for the x. I'm going to subtract y from both sides, and I have x equals 6 minus y. Now I'm going to substitute that in the second equation and just solve for that y. So I'm going to take the x out and put 6 minus y in its place. Minus 2y equals negative 2. Let's distribute. 3 times 6 is 18. 3 times minus y, or negative y, is negative 3y. Then I have the negative 2y here. That's equal to negative 2. I have 18, negative 3 minus 2, that's negative 5y equals negative 2. I'm going to subtract 18 from both sides. I've got negative 5y equals negative 20. I'll divide by negative 5. And I got y equals 4. Now, let's use y equals 4 in one of these equations. It'd probably be easier to use the first one. So I've got x plus 4 equals 6. Let's subtract 4 from both sides. We got x is equal to 2. So when I write my final answer, I write xy equals 2, 4. 2 plus 4 is 6. 3 times 2 is 6. 2 times 4 is 8. 6 minus 8 is negative 2. So this checks out. I feel good about the answer. Number 3, using elimination. This is where I'm going to do some multiplying, I think, here. No, I don't think so. I don't think I'm going to multiply at all. Because when I see this, I was looking for, so I would have opposite coefficients in one of the variables, and negative 3y and positive 3y is going to do that. So I'm going to add those right as they are. 4x plus 2x is 6x. Negative 3y plus positive 3y is 0. Negative 22 and positive 16 makes negative 6. So I'll divide by 6, and I've got x is equal to negative 1. Now I'm going to put this in either the first equation or the second equation. So maybe I will put that in the first equation. 4 times negative 1 minus 3 times y is negative 22. So negative 4 minus 3y equals negative 22. I'll add 4 to both sides. I'm looking at negative 3y equaling negative 18. Dividing by negative 3, I got y is equal to 6. And my final answer, I'll write the ordered pair negative 1, 6 for xy here. And this is negative 4 minus 18. That does equal negative 2. This is negative 2 plus 18. Negative 2 plus 18 is 16. We got the right answer there. All right, now this one. 2x minus 3y equals 12. Negative 4x plus 6y equals 36. I'm going to do all three methods. You choose. I'm going to graph first, though. And if I'm graphing this one, maybe I'll make a table with this one. X, y, let x be 0. And 2 times 0 minus 3y equals 12. That's negative 3y, because that's just 0, equals 12. Divide by negative 3. Y is 4. Okay, let me get a 0 for the y here. And that is 2x minus 3 times 0 equals 12. 2x minus 0 is 2x equals 12. Divide by 2, I got x is 6. 0, 1, 2, 3, 4 is here. 6, 0, 1, 2, 3, 4, 5, 6, 0 is here. Okay. Now, I am just going to draw this line as carefully as possible. All right, did this one in black. I need to graph the other line. So this line is graphed in black. Let me graph this one in green. This time, I'm going to choose a method that I saw a lot of you doing. I'm going to solve for the y. I'm going to add 4x to both sides. I've got 6y equals 4x plus 36, just putting the x first, divide through by 6, y equals 4 sixths x, and 36 divided by 6 is 6. I'm going to simplify 4 sixths to 2/3. Y equals 2/3 x plus 6. So it goes 6. Okay. I'm just checking everything here. Oh dear. You know, I'm looking at something here. 12 divided by -3 is -4. So I'm going to redraw this line. First mistake of the year, guys. That's -4. This is not the line. This 6 0 is okay. 1, 2, 3, 4. That's right there. Alright. That line is actually going like that. Now, y equals 2/3 x plus 6. Now I'm ready to graph the green line. I corrected this one. Hope everybody caught that. I had -3y. 12 divided by -3 is -4. I didn't have that at first. Alright, so 6. 1, 2, 3, 4, 5. 6 is the y-intercept. I'm going to go up 2 over 1, 2, 3. Up 2 over 1, 2, 3. I'm going to go down 2 over 1, 2, 3. 1, 2, 3. Down to 1, 2, 3. It looks about as far as I'm going to get. Alright. Those lines are parallel. Those lines are parallel. When they are parallel, there is no solution. There is no single ordered pair like an xy like this that will satisfy both this and this. Those two things will never cross. Let's see what that looks like now that we kind of know the answer already. What if we tried elimination here? 2x minus 3y equals 12. Negative 4x plus 6y equals 36. Let's say I'm looking to eliminate the x's, and I multiplied this one by 2. And I got 4x minus 6y equals 24. And here I've got negative 4x plus 6y equals 36. And I go ahead and add, and those cancel. That's 0. Oh dear, those cancel too. That is 0. This whole side is 0. 24 and 36 makes 60. 0 is not equal to 60. So you would go with no solution there. Look at this right here, guys. You know how I got y by itself? If I were to use substitution, I would get y by itself or x by itself somewhere. And since I already have this, I'm going to substitute this into the first equation. So elimination, this is elimination. Substitution, I've got 2x minus 3y equals 12. I solved for that y equals 2/3 x plus 6. Is that the right one? Yeah, that's the right one. So I'm going to put 2/3 x plus 6 right here. So I've got 2x, this is substitution here. I'll just write sub there. 2x minus 3 times 2/3 x plus 6 is equal to 12. So that's 2x. 3 times 2 is 6. 6 divided by 3 is 2. So 2x minus 2x, negative 3 times 6 is negative 18, is equal to 12. 2x minus 2x is 0. So we got negative 18 equals 12. We lost our variable again, just like we lost our variables here. If it's not true, and you lose a variable, it's no solution. So any way you look at it, we're coming up with no solution. Alright, number 5, you guys get the point. When I look at this, I think I'm going to use elimination here. I'm not going to graph all three this time, or graph and then use substitution. I'm just going to go with elimination just this one time. And I'm going to multiply this thing by -2 because my goal here is to eliminate the b's. And I'll have -10b and just leave this one alone. And this one, I got -6a minus 10b equals -2 times -27 is +54. Those cancel. Looking at -2a equals 8, and I'm dividing by -2. I'm getting a equals -4. I'm going to take the a as -4 and put it in the first equation. 3 times -4 plus 5b equals -27. -12 plus 5b equals -27. I'll add 12. 5b equals -15. I'll divide by 5, and I got b is -3. So this time my ordered pair is AB equals -4, -3. Just going to check that real quick. 3 times -4 is -12. 5 times -3 is -15. That does add up like I want it to. This is 4 times -4, which is -16. 10 times -3 is -30. -16, -30 is -46. How long has that been out of focus? All right. And that's what I've got there. And I used elimination. That was the method of my choice this time. This one, let's see. In blue, I'm going to graph this line. And I'm going to use my boundary line is y equals 2x plus 3. And I'm going to make it solid. Do you know why? Okay. 1, 2, 3. Let's go up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. Down 2 left 1. I'm going to fill the grid. Go from one end to the other. All right. My note card's not long enough for this great big grid here, huh? Okay, I said solid with this. All right, there's that. Now I got a shade. I'm going to use the test point of 0, 0, which is right here. 0 is greater than or equal to 2 times 0 plus 3, which says 0 is greater than or equal to 3. Anything on this side, like 0, 0, gives me a false statement, because 0 is not greater than 3. So I'm going to shade lightly here. I'm going to do this one in green. Boundary line, y equals 1/3 x plus 5. I'm going to make it dotted. 1, 2, 3, 4, 5. Up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Whoops, 3 here, not this one. Okay, let's go down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Okay, dotted line. Dotted line. Okay. This time, I'm going to use a test point here again of 0, 0. And I have 0 is less than 1/3 times 0 plus 5. 0 is less than, that's 0 plus 5 is 5. That is true. 0 is less than 5. It's the green line, test point's here. I'm shading down toward that test point, this test point here. All right, and if you'll notice, I'll do this in red, that this section is the section that has all of the solutions in it. The ordered pairs in this section satisfy this and this inequality. It would be true in both. So right here, this heavy shading is the answer there. One more. I'm going to do two different ways. This one, I'm going to convert on the boundary line. It's 3x plus 4y equals 12. I'm going to subtract 3x from both sides. Some of you like this. You like the slope-intercept when you're going to make the line. So I'm going to do that for that group of people. Negative 3/4 x plus 3. And I'm going to make a solid boundary line for both of them, right? So I got 1, 2, 3. I'm going to go down 3 over 1, 2, 3, 4. Down 1, 2, 3 over 1, 2, 3, 4. I'll go up 1, 2, no. Yeah, up 1, 2, 3, go over 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. I want a little more than a note card there. That's all right. Let's just use a note card. It's a solid line. Just move it. And test point 0, 0. 3 times 0 plus 4 times 0 is less than or equal to 12. That's 0 on this side. That's less than or equal to 12. That is true. Test point's right here. So I'm doing this side for this line. And for, let's go blue here. The boundary line I'm dealing with is 6x minus 3y equals 18. I'm going to make a table for this one. When x is 0, it's 6 times 0 minus 3y equals 18. Running out of room. Negative 3y equals 18. Divide by negative 3. And y is negative 6. When y is 0, we take 6x minus 3 times 0 equals 18. That's 6x equals 18. Divide by 6. And x is 3. 0, negative 6. Right here's 0. 1, 2, 3, 4, 5, 6 right here. And 3, 0. 1, 2, 3, 0 is right here. Solid line. Careful. All right, now test point 0, 0. So I'm going to, which one am I doing? This one right here. 6 times 0 minus 3 times 0 is greater than or equal to 18. This is 0 minus 0 is greater than or equal to 18, which is 0 is greater than or equal to 18. 0 is not greater than 18. Test points here, my line's here, the blue is doing here. Alright, so I'm below this line, I'm below this line. Go in black here. Alright, and this shaded region is the region, these ordered pairs all fit here and here. It's true all the time. Okay, I didn't write false here. I didn't write true here. That is an important thing there. Alright, guys, that's what I have for you. I'm going to close it.